Hello and welcome to the world of artificial intelligence. Today we are diving deep into one of the most transformative technology in AI, neural networks. These algorithms mimic the structure of the human brain, enabling machine to learn, adapt and perform tasks that were once thought to be uniquely human. In this video we will explore how neural networks work, their components and how they power real-world applications. Let's get started. First off, what exactly are neural networks? Neural networks are machine learning algorithms inspired by the brain. Neural networks are types of machine learning algorithms inspired by the structure and function of human brain. They consist of interconnected nodes or neurons, which work together to perform and learn from data, much like our brain processes information. Key functions are pattern recognition, classification, and predictions. This network access at tasks like image recognition, natural language processing, and even predicting analysis. At their core, they are designed to identify patterns, classify data, and make predictions based on the input. Nextly, we have the architecture of neural networks. Let's break down the architecture of a neural network. First, input layer. First, we have the input layer. This is where the raw data enters the network. It can be image, text, or sensor reading. Second, hidden layers. Next, hidden layers. The layers perform complex mathematical computations that help the network learn exactly important features from the data. The more hidden layers you can have, the deeper the network learning ability. Finally, we have the output layer, where the network makes its final prediction and classification based on the patterns it learned from the previous layers. Next, we have activation functions and layers. Now, let's about the activation functions. Activation functions are non-linearity. Functions like sigmod, relu, and tenant are the used to introduce non-linearity into the networks. This helps the network learn complex patterns, something linear functions simply can't do. Fully connected layers, conventional layers, pool layers. There are also different types of layer. Fully connected, conventional layers, and pooling layers. Fully connected layers connect each neurons to every neurons in previous layer. Convolutional layers, commonly used in image tasking, apply learnability filters to detect patterns like edges or sharps. Pooling layer reduce the spatial dimension of the input, making the network more efficient. Next in we have supervised learning with neural networks. Neural networks can be used in both supervised and unsupervised learning scenarios. What is supervised learning? Supervised learning is data with labels. In supervised learning, we have data labels. The network is trained on this data and is adjust its weights and bias using a process called backpropagation to improve its predictions. Next in we have the unsupervised learning with neural network. What is unsupervised learning? Unsupervised learning is unlabeled data. In unsupervised learning, the network works with unlabeled data to discover hidden patterns. For example, it can automatically extract features, perform clustering tasks, or reduce the dimensionality of the data to make it easier to visualize. Next, in we have implementing neural networks in Python. Let's now talk about how you can implement neural networks in Python using popular libraries like TensorFlow, PyTorch, and Keras. TensorFlow and PyTorch are two powerful open source libraries for building and training neural networks. TensorFlow provides a robust framework, while PyTorch offers a more intuitive approach. Keras, on the other hand, is a high-level API that simplifies neural network creation on top of the TensorFlow. With just a few lines of code, you can create and train your own neural network to tackle complex tasks. Let's say you want to train a model to recognize handwritten digits. You can use the minimalistic dataset, preprocess the data, and then build a model using layers like dense, dropout, and convolute 2D integrals. Next in we have optimizing the neural network performance. Optimizing your neural network is essential to achieve top performance. Hyperparameters like learning rate, batch size, and the number of hidden layers can affect, significantly affect how well your model performs. Tuning them carefully is a key importance accuracy. Data augmentation. Data augmentation, such as rotation image or generating synthetic text, can increase the diversity of your training data, helping your model generate better regularization. Regularization technique like dropout and LT2 regularize the prevention, outfitting, and ensure the model can adapt to new data effectively. Next, we have real-world applications of neural. Now, in this topic, we will be discussing the real-world applications of neural networks. So, where do neural networks shine in the real world? It shines in the computer vision. Neural networks are revolutionary computer vision. Everything from image classification to facial recognition is powered by using algorithms. They are used in security, healthcare, and autonomous vehicles. Next, we have natural language processing. In natural language processing, neural networks enable applications like language translator, sentiment analysis, and intelligence chatbots. Predictive analysis. Neural networks are also widely used for predicting analysis in finance, healthcare, business, weather, helping companies make better data-driven decisions. Autonomous system. And of course, it is an autonomous system like self-driving cars. Neural networks help machines perceive their environment and make decisions on the fly. What are the key takeaways in this PPT? So, it is the bottom line of neural networks. Neural networks are incredible, powerful, and flexible algorithms that mimic the way our brains work. They are used across a wide variety of applications, from computer vision to natural language processing. While they require significant computational power and data, their ability to learn complex patterns make them invaluable in AI. Thanks for joining me on this journey through the world of neural networks. If you found this video helpful, don't forget to like. Drop a comment below if you have any questions or want to see more examples. See you in the next video. Till then, keep learning. Thank you.